So this question is about Brownian motion. So Brownian motion, you may have seen this where you have a um, small container into which you can place smoke. There's a bright light source from one side that lights up the cell. You may put a cover over the top once the smoke is inside, and then you've got smoke in this part here, and it's get lit up very, very brightly. Then microscope comes in here, and you then look down through the eyepiece at what you see. And what you see are points of light that appear to be dancing around. And if you're looking at it through this, you'll see convection currents as the heating affects. You'll see sometimes the points of light will drop out of focus and move back into focus. But generally speaking, what you'll see is it's a really nice experiment. You'll see points of light sort of jumping around and moving about in this jerky, random walk motion. So it moves around apparently at random. And the description of that, this explanation of that, which was given to us, Einstein came up with this, among a few other things. This idea that it was due to the bombardment of the subparticles. So the subparticles are large enough to reflect the smoke, reflect the light. The subparticles within the smoke are large enough to reflect the light. And what you're seeing is the effect of them being bombarded by gas particles in the air at very, very high speeds and making these relatively large subparticles move around. And what you're seeing is the effect of them being bombarded. So let's have a look at these four descriptions and see which ones fit. So smoke particles gaining Ke by absorption of light. No, nothing to do with it. We see them because they reflect light, but yeah, nothing to do with that. Collisions between smoke particles and air molecules is definitely something that's happening. So we're seeing the observation randomly when viewed through a microscope. Yep, so that makes sense. Smoke particles moving in convection currents caused by the air. So they do drift and move around, but that's a fluid flowing motion. It's not them jumping around. So although that is a statement of something that happens and that is observed, it's nothing to do with Brownian motion. The smoke particles moving randomly due to their temperature. Again, the temperature of the smoke particles themselves has no effect. It's the temperature of the air around it, and therefore the speed with which they're being bombarded. So the correct answer is B.